Okay, this demo here is on the idea of traveling waves and the two different types, a transverse wave and a longitudinal wave, along with how the medium can actually affect the speed of the wave. So what I've got here is a long slinky, long spring here. And first I want to demonstrate what a transverse wave is. Now, a transverse wave is described as a wave that travels, moves down through the medium, but the wave moves perpendicular to the wave's velocity. In other words, the wave itself will move with a certain constant velocity down the spring, but the shape of the wave, the movement of the medium, will be perpendicular to that. So as you can see, as the wave moves forward, the medium itself moves at a 90-degree angle to that. And that's basically what a transverse wave is. Let's watch that again in slow motion. The second type is a longitudinal wave. Now, a longitudinal wave, the wave moves parallel to the wave velocity. The medium itself is compressed, so it's sometimes called a compressional wave. So you compress the medium, and as you can see, that little compression there moves the medium back and forth, or forward. In other words, parallel or the same direction at which the wave actually moves. Let's watch that again in slow motion. So transverse wave, perpendicular. Longitudinal or compressional wave, moves parallel. Now you also notice in each one of those cases, the wave doesn't last very long, nor does it move very fast. Okay? And that's because of the medium itself, the density of the medium. So let's change it up to a more dense medium. Okay, now in this case, we have a much more compact spring, smaller and more dense. Now again, let's look at that transverse wave, the one that moves perpendicular to the direction of the wave velocity. Now as you can see, that wave moved a whole lot faster and actually lasted a lot longer, okay, because the density actually affects the speed of the wave. The more dense the medium, the faster the wave can actually travel. Let's watch that again in slow motion. Now, for the longitudinal wave, it's a little harder to see because this is such a compressed medium. We'll try to do it here. Probably couldn't see that, it was so fast, but that little compression, again, goes very much faster because the velocity gets higher as the medium gets more dense. Let's watch that again in slow motion. There you have it. Transverse wave and a longitudinal, or often we call compressional wave.